Hi everyone. So this is my submission for the Atlan assignment, the front-end assignment that I was given. I had previously submitted my solution, but after consulting a senior, he said that I should, try to not just complete the problem statement that was given to me, but actually try and enhance or implement whatever more I can. So this is my attempt at the same. So this is the updated GitHub repository, this one. What I've done is I've created the backend as well, and now the app is fully functional. I'll show you the demo of the app first. So this is how the app looks right now. See, as you can see, the backend is connected. I have deployed the backend on render. If I click on this link, I've created a simple root get request route, and that just displays backend is running to just kind of a health check. And the database is in a CSV format that has already been uploaded on the backend. So this is something that I will do in something that has been done. It scans the CSV and sends all the columns in the CSV. It also, the backend itself sends the queries that can be executed, the predefined queries. And there is also this time which it took to the for the data to be displayed properly. This is from the moment the API request was made to till the moment the data was successfully rendered. And there are multiple things that have been implemented currently. I'll go walk through it one by one. So there is a predefined thing. As you can see, it took 2 milliseconds, and it shows the number of records that is being displayed correctly. There are multiple predefined queries, right? And you can actually edit the SQL that is being shown here. Let's say we go to select all orders, and I write limit as 67. When I run the query, it only shows me 67 records. Whatever the SQL that should be there, it just does what it should do. Right? I can also do like return. I can select maybe a customer ID, and I write like this. And when I run the query, it just gives me the correct output, right? And I can also do one thing. I can let's just say I go here, and let's just say I come back here, and now I just want all the orders from this customer. So let's just say I write this, and I get all the orders from this guy. When I can just remove this thing, orders, and when I run the query, so now these are all the orders. And when I write again, right, so it shows all the orders from this particular customer. Okay. As a backend is there, right, as I told you. And yeah, it also shows how many of the records are being shown out of total records based on the predefined query that was earlier done, right? So this was the front end part. Now I can let's just go to the backend part right now first. So let me show you in code. Yes. Yeah, so this is the backend. This is just the standard things that we get. This is the main file server.js. It's uploaded on it's deployed on render, and we're doing nothing. We load the CSV data. The CSV is uploaded right here, right? Just a second. Okay, so let's deep dive into the front end code, right? So there are four main components: the result table, the selector, the input, and the backend status. I'll just show you here. So this is the backend status, this is the result table, this is the query selector part, and this is the query input part. Right now, let me explain basically app.jsx. That would be sufficient to get the idea of what is happening in the code. So uh, first of all, we initialize the engine. So SQL engine is nothing but a class. It just stores the API endpoint of this guy, and it also stores the fact that if the database is initialized or not. So the way the backend was designed was that first of all you need to hit a slash API slash init route to initialize the database itself. The way backend was designed is not by connecting to an actual SQL server, but by using SQLite in memory. So first you would need to load the CSV data into SQLite. So that is done by init method. That happens uh, whenever the page is rendered for the first time, right? That is what we wanted. Now let me first go here. Okay, this is nothing, this is simply backend status class. It's a very simple class. um, this just takes the is initialized in backend URL. Just you can see here, this shows connected. This is the backend URL, right? Let me describe the result table first. So result table takes the result thing, the results. These results come from the init part, as you can see right here. See, I got the result from the execute query basically. So yeah, execute query also gives a result, and init will also give a result, but that's okay. Now we also, once we got the result, we can't store it just like a variable. We need to use state right now. There is no state management as such. I am just using use state right now. Then after that, let me just go into the result table itself, and I'll show what's happening in there. So what I have used for this is shared CN table component. As you can see right here. See, earlier I was using the for more optimized thing, I was using React virtualization. Let me just remember the name. It was I'm not able to. I think it was some a React virtualized React window, something like that. Yeah. So it was using that, but what happened was that I was not able to perfectly create this type of situation like the columns were not able to get synced with these things. So I decided to not proceed with that, but that would, if if I could have made it work, it would have been more optimized than it is currently, because what it does is it does not load the data of what you are not viewing currently. For example, if I go I'll just run this query. So what it will do is it won't load any of this right away. It will just render the part that I am currently viewing in the viewport, this part. It won't have rendered all of these parts when I'm looking at this. Okay. Now I'm also one of the good things that I'm doing right here is I'm using use memo, right? So what is it is doing is, see, what use memo does is that it won't re-render certain parts of the things until some other parts of the thing that I will define won't change. For example, if the data itself is not changing, this data, or maybe I'll just write Tom maybe. So if this data does not change, those components will not change, and those will remain same. Those will remain same throughout. So I'll just show you one by one what is happening. So all the columns need not change until and unless the data itself changes. That is not changing right now, right? The data will, how will the data change? Let's say for example, I just do customer ID, right? So I did customer ID, I ran the query. So it is taking a little more time, right, as you can see. So because it needed to get the data from the backend now, and this also need to be re-rendered, and I'll move ahead and I'll show what's happening. So after that, process data is nothing but whatever you, let's say, Tom you write. So this is the process data. Now I'll show from here. This is a better way to show. So this is an input component. This is a shared CN UI component, this input.jsx, and I'm using this input component right here it helps me with, very easily apply filtering, right? And then I'll show you about this thing. So this is a table, as you can see, table header, table row, table header, table row. And now first of all I need to map the columns. So so this is a request sort function that I created. So there is a thing, yeah, I forgot to show. So this has been done. If you click on, sorry, just a second. Okay, so as I was explaining, so what this thing is the heading part of the table. Okay, now what it does is simply it gets the columns that it previously had right here. Let me just show you. It rendered it whenever the data was changing, it was fetching the columns, right? So as soon as it got the data, it fetched the columns, and then what it did was it mapped the columns onto table heads. These are the table heads. And then there is an on click functionality right here. So what the on click functionality is doing is it's sorting the columns, and also yeah, so let me just explain this first. So this is a data that is being displayed, because that's what the column thing contains. And then after that, uh, this is what is there's a span added for the arrow thing. So what is happening here, I'll explain really quickly. So it assumes the initial direction to be ascending, like as it is. And no, initially it assumes nothing, and it's just displaying the data as it is. When once you click on ascending or descending, it sorts the data based on whatever you clicked, right? So it calls the request sort function. So request sort function is right here with us. So it assumes direction is ascending if the key that it got, key, this is that is right here. So if the key that it got was ascending, then it would sort it according to ascendingly, or if not, then it would do it using descending. So right now let me show you what will I show you. Okay, so now let me show you the body part. So in body we are just mapping the processed data onto the table rows one by one, and then onto the table cells one by one for all the columns, right? Then let me just discuss processed data for a moment. So processed data is functioning. So whenever the search term changes, let's say I wrote Tom, so the data is changing. So this is the filtering thing. So whenever you change the search term, so you first of all need the filtered data to then sort it out, right? So this filters the data according to the search term. It does nothing, but it just filters, converts it, the search term, into lowercase, and just checks if any of the cells match these particular letters in lowercase. Then it adds them into the shallow copy that we created for filter data. Right now I think this is enough for the front end explanation. I can explain the back end a little, and then I would explain the limitations and possible future improvements that we can do. So let me quickly explain what's happening in backend. So in backend I'm using SQLite, right? So this is basically a memory based database. It is not an actual hard database that you can connect to over the web. So that is a possible, no, that is definitely a current issue with the implementation, right? So what it does is, what the backend assumes is that you would have a CSV data already present in the public folder, right? I haven't added the functionality to upload your own CSV files, but that is also a future enhancement or feature that I can add, that you can, upload your own CSV right here, and it would send the CSV here. Now what would happen once the CSV is with us is that first of all you would let me just show you. first of all, you would want to run the uh, okay, just a second. Okay, so first of all, the middleware would run whenever you get a request, obviously. So what will the middleware do? It will go to the check database ready function. Now check database function, um, it does the following, that if if the request that I'm getting is initialize or health request, it just forwards it. If the database is not initialized, it returns that you need an initialized database. Now what does initialized mean? So initialized means that the data that is present in the CSV file should get converted into the a memory based database that SQLite can use. So this is exactly what is happening in the load CSV data function, right? So there is a variable known as is initializing set right here. This is set to false initially, so that's what we want. So now after that, uh, while it is as long as the initialization thing is false, it will keep on loading the CSV data onto the SQLite. And after it is done, now what happens is pretty simple. Now oh sorry if you call load CSV data and the database already initialized, then it just okay, sorry, it if the database is already initialized, then it will sorry, I'm just a bit anxious. Okay, so okay, so I'll explain using the init route first of all. So if the database is initialized and it is not in the process of initializing, now we need these two things. Okay, we need the table info and we also need the result, the count result basically. So the count result goes right here. Um, we need to send all of this to the front end side. So if if the database is already ready with us, we just return it as it is. Otherwise, we perform the load CSV data thing, load CSV data function. Now let's go on to the API/query part. Now if you get a query from this, like I sent a query right here. So now what will happen is, it will run the query using the SQLite run query function right here. And we can also use the get function to get the schema for the tables. Sorry, you can get the schema information right here. Now you would ask, why would you need the schema information? So this part, the available columns, is sent using the schema information only. Right now there is only a singular table right here. So now I'm going to discuss about the possible, the first limitations and possible future improvements that we can do here. Okay, so um, so let's first discuss the database limitation. Currently we are using a SQLite file based database, which is not suitable for a very high concurrent access and also is limited to a single database file. This could become a future bottleneck for larger data sets. It also does not provide us with complex optimizations that we could possibly do with an actual database management system. Okay, now we can move on to the limitation that we are currently having with in terms of backend. So backend is not at all scalable right now. If we were to really make a backend that could execute all these queries, it would need to be much more divided. It is currently a single server architecture with no balancing or no caching that's done. So those are the limitations, as well as the possible improvements that we can do. That is, we can we can create a sort of microservice structure for read write queries, and we can also we are also not currently providing write queries, so that is also something that we can do later on. Now for the front end part, all this data is loaded on the client side, which can be very large. So rendering large data is always a problem. And for that there are multiple optimizations that we can do. Number one being we can implement pagination. Now I was going to go with pagination, but it does not look that appealing, so I did not go with it. I liked the scroll part, so I really wanted to um, scroll the database very freely, so that is why I didn't go with pagination. But yeah, that is actually much better when dealing with larger databases. And we can also do the React virtualization that I previously mentioned. We can use the React virtualization component, the library, so that it only loads or renders the page, the data that we are currently viewing. Right. Also, there is no state management in this, so there is no persistent state management. So the data will get destroyed. Like if I do Tom and I reload, and maybe if I do Tom, uh, let's say Tom, and I just go right here, and when I come back to all orders, the data is not there. So there is no state management. These are the main overall things that we can improve and what are wrong with it right now. So thank you.